All right, please remember tomorrow is your first test. You do get the whole period to work on it. You probably won't need the whole period to work on it. Again, it's kind of modeled after the two we did yesterday, but it's just going to be one problem. All right? I've actually written two problems. I'm trying to figure out which one to pick. So, I know I don't need any suggestions. All right. So, today we're going to go over Chapter 6. All right? And we'll first go over these PowerPoints, and then we're going to go over and redo the payroll program. Okay, I've modified it a little bit. I'll explain why and how, etc. when we get to that point, all right? This stuff we're doing today will not be on tomorrow's test. There is nothing that's object-oriented in nature that you'll have to do for the test tomorrow, all right? But it will be on the next test that we'll take, not next week, or maybe we'll see how it goes, either at the end of next week or the beginning of the following week. All right. So in this chapter, they discuss objects and classes, how to write a simple class step by step, instance fields and methods, constructors, passing objects as arguments, scope of instance fields, and package and import statements. All right, I don't want to sit there and read this stuff to you. Hopefully you realize by now when you talk about object-oriented programming, an object is kind of like, for lack of better words, it's a container, and it holds both data that are typically referred to as fields or attributes, and methods that perform operations on that data. That's it. All right. Sometimes the methods are referred to as behaviors. You know, they do go by different names. It just depends on the book you read. So this is Tony Gaddis's book, so this is Gaddis's take. All right, so you should at least know a class is a blueprint. We're going to see that in a minute. And from the blueprint, you build objects. All right, we are all of the class person. All right, we all have a height. We all have a weight. We all have an eye color. All right, for a while yet, I'm still going to have a hair color. All right, etc. But we all have things that make us unique. We all have those attributes, but the attributes are different for each and every one of us. Okay? All right. As it says, we've already worked with some objects. We used the random number object. And if you remember, we had to do a new random. When we did scanner, we had to do a new scanner. I showed you the print writer. We had some problems with that, or at least I did. All right. So Java is filled with literally hundreds of built-in objects. If they don't do the trick, you can go and create your own objects. And really what the hallmark of object-oriented programming is it's different objects being able to communicate with one another by passing messages back and forth. Those messages are basically method calls. And when you think about it, that's not really very different than the way you and I communicate. All right, we're person objects and we communicate via speaking. We use a speak method. All right, that kind of thing. So what they're saying here is it's not that different. I mean, in fact, a lot of books that you read that talk about object orientation, they'll say objects are all around us. Just look here. I've got a computer object. I've got a desk object. I've got a microphone object, etc. All right. So again, it says a class is code that describes a particular type of object. Typically, a class is referred to as a blueprint. All right? And maybe I said this the other day, maybe I didn't. I don't remember anymore. But it's like if I do decide to build a house, my hope is that the person that I build it from, I can see the plan ahead of time. I'll see a blueprint of what the house is supposed to look like. Now, you might think, well, of course, you'll always do that. I will tell you that years ago, I was living in northern Wisconsin, and my wife's brother-in-law introduced me to this guy who was building his own house. The guy was really talented. He was a carpenter. And I remember talking to him and saying, do you have a blueprint? No, I'm kind of doing it all in my head. If you would have seen the stairway that the guy ended up having to put into his house because of the way it was built, And what he did, it was probably about half the width of a typical stairway. Two people could not go up and down it at the same time. That's just the way that he set it up. Only one person at a time could. I mean, the house was great. It was a fantastic house, but he didn't have a plan ahead of time. He did a lot of things off the top of his head. So as it says, you can think of class as a code blueprint that can be used to create objects. All right? When the program runs, it uses the class to create as many objects as needed. Today, we're going to do this, and I happen to create 5 objects. All right? What we will do when we get into the next chapter is we'll create an array of objects. Now, hopefully you remember this, because this is just like C#. When you create an array in Java, they have to all be the same type. But we can make an array of objects. We can do that. But if I make an array of objects and I say it's going to be this class, and I make an array of 9 objects, now if somebody else joins us, I can't do that. That array, once you set it, it's set at compile time. On the other hand, we can create an array list in Java, and an array list has got 16 members by default. What happens is, unless you tell it otherwise, once it fills up, it gives you another 16. All right, it gives you 16 by default, but I can change that. I can change it with an array list, so automatically it gives me 1,000 empty objects. And as soon as I fill those up, it gives me another 1,000. I could even do it with 1,000,000 if I wanted to do that. All right. Every time that you create an object, it's called instancing or instantiation. All right. So here is an example. Virtually every time you create a new object in Java, you use the word new. There is one exception. You already know what it is. So if I do this, if I come in here and I type in string first name equals Jeff, that's the same thing as if I type in string first name equals new string Jeff. You can actually do it the second way. I can't think of anyone who does, because it involves typing a lot more. You know what I mean? It's probably a good dozen or more keystrokes. I don't know, maybe it's 10. Doesn't matter. But they do the exact same thing. But what is built into the string class in Java is it says that basically, hey, if you do it like this, do this to it. All right? And it's not a big thing one way or the other, but it's just sometimes people see the second one, they're like, I didn't know you could do that. Well, when you do the first one, it does the second one behind the scenes for you. All right? Hopefully that makes sense. All right. And again, random number, print, they're showing you a bunch of examples. The Java API provides you literally hundreds of classes. When I started teaching this, I wish I'd have counted, but I didn't. My guess is if you looked at the API when I started to teach this, probably 20 years ago or whatever it was, the API probably was about 10% of what it is now. With every new version, Java adds more and more and more stuff. Why? Why do they do that? What's that? To make it easier for you. And you're right. You're 100% correct. But even more basic than that, because they want you to use the language and keep using it. So every time they can automate something for you, there's a better chance you're going to go, oh, that's cool. I don't have to do that. All right? That's what they want. And Java has done a good job of doing that over the years, and that's one of the reasons it's still one of the most popular programming languages. All right? In this chapter of the book here, all right, they create a simple class that they call rectangle. Okay? And what they're saying is a rectangle will have 2 fields, a length field and a width field. All right? I think you'd all agree right now if I said, hey, here's your test. Pull out a piece of paper and draw me a rectangle. You could all do it, but the chance of every single one of you having the same height and the same width in your rectangle probably are not very good. All right? The reason I'm telling you that is length and width, those are known as instance fields. So every time I create a rectangle, each rectangle will have its own length and it will have its own width. On the other hand, if I came over here and I don't want to go onto the slide, but if I came over here and said we got another field here that was called rectangle count. All right. These two are instance fields. There's one for each instance. This one would be a class field. I'd only want one count. That should make sense to you. All right, so if I make 1,000, I want rectangle count to equal 1,000. But I could conceivably have 1,000 different lengths and 1,000 different widths. All right, there's absolutely nothing wrong with doing that. All right, but I want you to get used to using these words. So instance means that every time I do something, that gets those instance variables. All right, and every time they all share, all right, something that belongs to the class. Okay? Now, I don't know if you remember this or not, but one thing that we have talked about is this word. You've seen that word before. You've seen that in other languages and in this language. For instance, in main, you see the word static. And one of the definitions of static is 1. So typically, this is going to be a static variable. These will not be static variables. This will be, main, you can have static variables, you can have static methods. And a class can hold one or the other or both. It's not a problem. And there's even other types of things that it can hold, and we'll get into that in the coming weeks. So, I don't know if this is going to help or not, but what I think I'm going to do right now is I'm going to go back and forth. You don't have to do this. You can if you want to. You don't have to. I'm going to literally build this class that they have in here, but I'm going to build it in IntelliJ IDEA because it'll give me the chance to talk about some of the stuff that's in here. All right, hopefully you'll find that that helps. I'm not trying to waste my time. I'm not trying to waste your time. All right, but if I come in here and into my folder where I've got my payroll files, okay, I'm going to add a new thing in here, and I'm just going to call it rectangle. Now again, do you have to do this? No. And in fact, it's funny because one of the new students asked me about that. Are we supposed to type in everything you are? And I said, it depends on whether or not you're turning it in. He goes, well, we're not turning this in. He said, it's kind of easier for me to just watch you do it, and I can learn much better that way. Then do that. Other people say, no, I've got to do what you're doing, because that's how then do that. All right? This is a very simple class, but the reason I want to do this is some of the stuff that's in here is not explained to any place in the chapter, all right? So, I'm going to come in here, I'm going to create a new project. You know this already, I don't have to say this stuff. So I'll have a new class called rectangle in just a minute. All right, there it is, come on. There it is. So the first thing that they want us to do in here, in this class, is they want us to create a couple of instance variables. Okay? So again, I want to do it the way they're doing it, so I'm going to bop back and forth between these. Okay, so let's see. All right, they made them both private. Okay. When you create instance variables like this, please look on the screen, okay? When you create instance variables like this, typically you want to create two different methods for each one. So I'm going to have a get height and a set height, and I'm going to have a get width and a set width. Did you hear that? Now, I can go in and magically type those in and it'll work just fine. But, and this isn't in your book anywhere, and it's the way you do this is different depending on the editor you're using. All right? But if you're watching me do this, if you go up here by code, see that? Up on the menu, if I go to code, because you're going to have to eventually do this, something like this. If you go to code and you go to generate, notice we got getter and setter. So I'm going to getter, and I want both height and width. Boom. There's my getters. All right, I come down here. I again do a code, generate. This time I choose setter, and I choose them both, and boom. Now all it's put in there are templates for me. Did you hear that? Okay, I can change this any way I would like to change this. I want you to understand that. It's totally legitimate to change these. All right, and I'm going to have to actually put something else up here in just a couple minutes. That's going to be the constructor that we're going to have in just a bit. All right, but don't worry about that right now. Put a few comments in here just to delineate what I'm doing. So, all right. Now, I have told you this before. You may or may not remember me saying this, but we talked before, and I mentioned to you the fact that these things that start with the word get, all right, they're also called accessors. And I gave you the example. I said it's the first day of class in September 2017, August 2017, all right? And, or whenever it was, 2016, whenever the hell it was. And Ethan walks into the room. He's the first one there. And he says, hey, how you doing? I said, fine. What's your name? And he says, Ethan. That is a get first name. Does that make sense? All right. If I decide that for whatever reason, you know, I literally, no joke, one semester I had a class with 3 Kathys in it. Okay? And it was what they all wanted to be called Kathy. It wasn't like a Catherine, a Kate, and a Catherine, etc. So 2 of them, I told them, I'm using your middle name. Okay? I asked them their middle name, and I said, unless you got a big problem with it, I'm going to call you by your middle name. Does that make sense? That's a set name. So I said, from now on, this is what you're referred to as. So if I want to change something, it's a setter. If I want to grab something, it's a getter. And guess what? Even more so, you know exactly what this means. Think about it from a database perspective. Remember when we did select statements where you could view data but you couldn't change the data? That's a getter. You're selecting something. But if you do an insert or an update or a delete, that is a setter. All right. Now, a couple things about this. Please look up on the screen here because the magic is all shown up here. When you've got a getter, 99% of the time when you've got a getter, it'll look just like this. I don't have to change either one of these. Not at all. Okay? But 99.9% of the time when you've got a getter like that, it has a return type that is not void. Very rarely, and you'll see an example of it today, very rarely will you pass anything into a getter. There's a reason that you may want to do that. We'll go over that later when we look at the payroll program. All right? But believe it or not, these 2 routines are both done. Now, when I go and I want to print out the value of height, I don't say the value of height is, I don't write something like this. I just want you to see this. So if I wanted to write the value of height right here, I'm not going to say system.out.println. Oops. The value or the current height is, we don't do this anymore. You don't do that in object-oriented programming. You don't write like this. You write like this. That's how you do it. You see the difference between the two? You're always sure you get the most up-to-date data because you're telling it to go out and grab whatever it is. You say, well, doesn't it get the most up-to-date data anyway? It should. I'm just telling you, this is the way that you do it. All right? If I decide that later on in my program, I want to change the height. Let's say the height is currently 10, and I want to change it to 20. I don't say height equal 20. I don't do that. I say instead, set height 20. You see the differences between these two? When we are accessing or grabbing the value of a variable, or when we're setting the value of a variable in an object-oriented language, you call routines to do it. You don't just sit there and do it yourself. And again, you might say, it sounds like it's more work. And you know what? It probably is. But you've got more control because you figure out what's public and what's not public. So you've got more control. And I have said this before. I'm putting this down. This is very simple. I shouldn't say that. 90% plus of object-oriented programming is what I just put there. It is using public methods to manipulate private data. Okay? And again, can you have private methods? Yes. They're called helper or utility methods. Can you have public data? The answer is yes. Should you ever, for any reason, ever have public data? The answer is no, regardless of what any book tells you or anybody tells you. Because once you make data in a class public, not only can anything in the class manipulate it, but so can other classes, because it's public. But you make your methods public so that other classes can call those methods. All right? In an ideal world, that's what you want to do. So what I have up here, these are just, believe it or not, these are two simple examples. But I want you, so this right here, that's how we do it in a procedural language. That's how we do it in a procedural language. That's how we do it in an object-oriented language. That's how we do it in an object-oriented language. All right? Now, looking at these other two, okay, these are setters. 99.999% of the time, a setter will never, ever return anything. Did you hear that? I can't think of a reason ever that you would ever have anything but void for the return type. Ever. Okay? But setters almost always have one or more things put into, passed into them. Does that make sense? They need to know what it is they're supposed to set. All right? Now, please look at the screen for about a minute or two, okay? Listen to me, but look on the screen. All right, this height right here and this height right here, they're two different heights. This height right here is the height you're passing in. All right? This is what you want to set that height to. And you go, so what? Who cares? Well, if you don't put the word this there, if you just do this, what it does is it takes the value that's right here, that's this value, and it copies it to right there. It will never work without the word this. Okay? So you need to put in there the word this. It's a key word. You can tell it turned blue. Now, let's say Tiffany raises her hand and says, okay, I get that. Do you have to do it that way? Well, let's look at another way you can do it. I don't have to call that height. I could call that H. Then I can just say height equals H. See the difference? If you want remember what these things are called? This is an actual parameter. Right there. That's its actual name. This right there, that's not an actual parameter. That is a formal parameter. And we've talked about for I was going to say for years, but for the last year and a half, that formal parameters and actual parameters don't have to have the same name. If you give them the same name in Java, if you do that, in order to distinguish one from the other, then you must use this dot. Now, some Java programmers always use this dot, even like this. Even if they make that an H, and you don't get an error. This just means the current thing that you're working with. All right? I think that in at least part of it, in C#, they use the word me instead of this. You have a question?
Oh, that was my question. Isn't that similar in C#?
Yeah. And they're not the only ones. I think there's this in JavaScript also, when you do some JavaScript object-oriented programming. So like I said, if this bothers you, then just change the name of your formal parameter. But if you want the formal parameter to be the same name as the actual parameter, and you want to make sure the actual parameter is getting changed, you have to put this dot in front of it. All right? All right. Kind of beat that to death, but. So there's the setters and the getters. Does it make sense to you, if you look up on the screen here, that if, I'm not doing this, but if I did this, if I did not have a set height and I did not have a set width, if I literally just got rid of them, then I could get things, but I couldn't set them. In other words, by removing a set routine, you're making it read-only, because I can't set it. All right? Now, do you ever do that? It depends on the situation. If there's something that you know you want to set and forget, you can do that. You can also do it the other way, where you don't have gets, but you have sets. Then it's write-only. That's very rarely done. But again, there could be a reason you want to do that. All right, so again, if you don't put in the setter, it's read-only. If you don't put in the getter, it's write-only. All right, I'm not going to go through this, but they talk about UML. Believe it or not, if you get a job as a programmer, you might do more work as a programmer analyst. All right, and you end up doing something that looks like this. This is a UML diagram, and it's what it is it breaks this class into thirds. That into this box. The top of the box is the name of the class. In the middle is the data, and on the bottom are the methods. Okay, that's how you do it. And you even go further than that. See if they show it. I'm going to have to go up a ways, but. All right. When you do this, sometimes you got a minus. Typically you have a minus. If you put a minus in front of both of these, it means that they are both. Or if you put minuses there, they're private. If you put plus signs in front of these, it means they're public. I can't remember what it is for protected, which is the other one, but we'll see it as we go on. So we know by looking at this, okay, we've got a rectangle class. It's got 2 pieces of data, and it's got 5 different methods. Wait a minute, 5? Set length, set width, get length, get. What is this get area? We're going to get to that. All right. So this is how we start. Again, do you understand the concept? I'm asking each and every one of you in here. When I said these are instance variables, do you understand what that means? That every time we create a rectangle, each rectangle will have its own height. Each rectangle will have its own width. It's totally possible to have two different rectangles with the same height and the same width. There's nothing wrong with that. You can have 2 people in a room that have the same height and the same weight, for example. All right. So we talked a little bit about these specifiers. when you make something public, it's not only available everywhere within that class, but it's also available to other classes. So again, when what we just saw in here, you'll notice each one of these routines, public, 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 public. That means that any other class can call these methods. All right, and plus if you look up on the screen here, notice the class itself is public. You know that every Java class we've worked with thus far has been public. That means that other classes, I can have another class that's going to eventually be able to come in here and do work with rectangle objects. All right. Private means that it's only available within the class itself. All right. And as we'll get to later, there's another one that's called protected. So this is the method header. I'm not going to read any of that, but just take a quick look at it. The key thing is what they say here. We don't have the word static in there. Why? Because we want to be able to set the length of each rectangle. We want to be able to get the width of each rectangle. All right? So none of those are going to be static. So there's a set length, and they do mention in here, again, notice they've used a different, they called it len instead of length, so they don't need the this. You've already heard me say that. So this is how you will end up creating a rectangle. Now, when you create a rectangle like this, okay, like this is what you do in main. But if you look up on the screen here, this file that we have, rectangle.java, is not going to have a main in it. This is just code. Remember last semester when we talked about creating those model files for ASP.NET and how they were just code? This is going to be the same thing. All right. This is instantiating or creating a brand new rectangle object. It's of type rectangle. Its name is box. All right. And we're not passing anything in. Okay. Well, then we can set its length when we get done. So if we don't pass anything in, maybe it just is going to default to 0 for length and width. Then we do a set length. We can also go in there and do a set height. All right. Another term that, just so you hear this, right now working with a rectangle object, the height and the width of a rectangle at any one time represents the rectangle's state. Object-oriented programming is all about keeping the object in what's referred to as a consistent state. All right? So in other words, you know it as well as I do. If I came in here and tried to do a box.setLength, and in here, if I put hello, the program would blow up because I'd be doing something illegal. All right, we talked already a little bit about get. This is what I mentioned to you before, so take a quick read, please. Does anybody remember another word for this? Anybody? Encapsulation. When something is basically hidden, all right, it's encapsulated. And I've given you the example before. If I do a Control P right now and I hit enter, I don't want to send that to the printer right now because it's going to print out 483 pages. That's one reason I don't want to send it there, and I don't want a hard copy of this anyway. But if I do that, and now if I go and click down here, if I come down here and I click print, again, I don't want to, but if I did, I don't know what happens to magically make that. I don't know how that stuff gets sent, across the wire or whatever it is. I don't care. I do care that if I try to print it and it comes back and it says it can't, then I care. So again, methods that retrieve data, they're called getters or accessors. Methods that modify data are called mutators or setters. Some books, just so you know, some books will call getters and setters combined, they will call them accessors. I wasn't taught that way. I was taught if you access something, it's basically read-only. All right. And this is what they're doing. And there shouldn't be anything in there that's like really a big surprise to you. All right, here's the thing on data hiding. An object hides its private data from the code outside of a class. I gave you that example the other day. I'm not going to do it right now, where I brought up the calculator and I typed in a number and I hit the square root key. And I said what I see is what's known as the interface. So 367, for example, boom, and hit the square root key. What happens to actually convert that into whatever the square root of 367 is, that's the implementation. So when they're talking about hiding this stuff, basically what you want to hide from people is the implementation. What you show them is the interface. All right. It says data hiding is important. Well, it's important for a lot of reasons, not just that reason. The other reason that data hiding is important, if I change the implementation, so if I change the way we're doing something in a program, but the interface to you looks the same, you don't care. Why would I change something? To make it work faster for you. Maybe to give you some information that you asked for that you're not currently getting. I don't know. What you don't want to get in here is what's called stale data. All right? What we're going to have in just a couple minutes, we'll have, for example, we'll have a routine called get hours. And we'll have a routine called get rate. All right? And we're going to also have a thing that's going to be called get gross pay. We're not going to have a set gross pay. We're going to have a get gross pay, and it's going to look like this. Return, get hours, times get rate. Now I'm assuming there's no overtime. But you get the idea? So we're going to be doing something that looks like that. All right? As it says, to avoid stale data, it's best to calculate the data within a method rather than storing it in a variable. All right? So you do it within a method, then you copy it over to the variable. All right? That's kind of what we're doing right here. So notice, look at, here's one time when we looked at all those other get routines. All right? It was just return something. All right? This is not well written, just so you know. This is not well written. Rather than returning length times width, it should be returning get length times get width. You should never, if you can help it, you don't put the names of variables in here. You use routines. So if I came back into my program here, all right, and that, why is that red? I don't know. Height, get height, return height, that looks good. Get width, return width. What doesn't it like? Cannot resolve method, get length. Don't Don't I have a get length? Oh, it's get width. I don't know what I'm thinking. Get height and get width. There we go. Doing it like that means that you're not going to have what's referred to as stale data. All right? And again, there's the UML, as I mentioned. Anything with a minus before it means it's private. Anything with a plus before it means it's public. Okay? I don't want to spend time going over UML with you because we're not going to do anything with it. Sometimes, though, what happens is you get, and I don't know if you understand the distinction with what I'm about to say, so if you don't, feel free to ask. But some companies employ people who are just programmers. Okay? Some companies employ people that don't program. They're called analysts. And some companies employ people that are called programmer analysts that do both. All right? But if I was an analyst, I might create something that looks like this and then give it to Colin. And Colin's a programmer, and based off of this, he creates something that looks like this. All right? There are actually tools that will take your code and build UML from it, or that will take your UML and build code from it. All right? To be able to go both ways like that, some of those tools are upwards of $1 million. All right? Because they will, the more you pay, the more code they'll actually write for you. All right? Not just these gets. I mean, I'm not going to pay $1 million for this. All right. Now, what they're showing you next, where he says here, class layout conventions, it's not mandatory that you lay things out in this order, but it's considered pretty much the way that people do it. All right? Now, I'll tell you one thing I don't like about having these getters and setters put in for us. Okay? And that is, if you look here, get, set, and technically, I probably should have, since this is another get, I really shouldn't have had it there. I probably should have moved it before my first setter, like this. But there's no law that says you have to do that, okay? There's some people that I know some professional programmers, they don't use this code generate, they do it themselves. Because what they like is they like their get height followed by their set height, and then their get width followed by their set width. All right, so I'd either have to manually move that, or I'd have to do it myself. All right? But what the author is saying here is you need some kind of protocol, some kind of an organized structure. So typically you put your data first, followed by your methods. And we haven't talked about this method yet, but there's a special method that runs. It's called a constructor. That usually is the first method that you put in your class after you put in your class data. All right, we already talked about what instance fields are. And I've already talked to you really about what an instance method is. Get height, get width, set width. They're instance methods. How do you know they're instance methods? They don't have the word static in them. All right. Instance fields and instance methods require an object to be created in order to be able to be used. So in other words, okay, right now, this program, no joke or anything, this program, it's totally useless. We have never created a rectangle object. You can't manipulate something you haven't created. All right? So they show you the different states of them. This is a good place. It's 1:20. Let's take a break. We'll come back at 1:35, and we will pick it up talking about constructors. I don't know how long this chapter goes. It's not real long. All right, there's 62 slides, so we got about 20 more slides. But now, believe it or not, it gets a little heavier with the stuff they talk about. So let's take a break. Please come back at 1:35.